so welcome to the podcast, everyone. This is episode 6. It was going to be about AI companions. We are delaying that because we just started talking about Sam Altman's testimony, and we tried to shove a little bit about prompt hacking, prompt engineering into the last episode. And I think it deserves its own topic. And I know that my two esteemed regular guests, Alex Papadopoulos-Korfiatis, ML research scientist, and Rafi Farouk, AI startup founder, know a thing or two about wrangling prompts to generate the right result. So let's get into AI news from the week before we get onto the theme. Thing I just saw this morning, I'm going to go first. Meta AI's Megabyte architecture, the end of tokens, which is also why I think it's really important to do this episode, because it may be hilarious that we even thought that worrying about tokens was something that people did at the beginning of the AI gold rush or whatever. So what blew my mind about this, so a couple of things. First off, you don't need to worry about tokens anymore. And it has a very, very clever way of threading together parts of your request. And you guys will understand that better than I do, I'm sure. But the thing I really like about it is that it can speak 10 times more languages than any other previous model. So it can speak 1,000 languages. And that is because it was translated on Bibles or trained on Bibles that have been translated. So it is curious to me, if you have a very regional dialect or a niche language that you happen to speak and you're listening, please try it and let me know if the answers come back very Christian or not. Because I think that's a possibility, right? So that's my news for the week. I wonder if you guys had seen that.
Alex, I'm sorry, I'm really trying to focus on what you're saying, and it's very interesting. But I just saw Rafi's background image, and it's what is that, Rafi, exactly? I am scared.
I actually wanted to ask Alex, I missed which model that was, but about my background image first. I just typed into DALL-E to AI friends rejoicing in happiness. And I think this also highlights the topic of bias, because it appears as if these people are from a certain part of the world. That said, DALL-E returned 4 different pictures, and I think it has attempted to show each set of people in each picture from a different part of the world, as if it's trying to implement diversity. So that's interesting.
Yeah, I've seen that as well. So I think that they have some kind of hidden prompt augmentation to try and like increase diversity of the pictures, which makes sense, I guess. If it's not in the model, then let's put them in the prompts at least. But sorry, Alex, though, going back to, I think Rafi, the model Alex is talking about is Megabyte, which is like, I don't know, an unfortunate name for me because it's like so common, right? But yeah, it's a paper by Meta about an alternative essentially to transform architectures. I'm not sure if Alex, they've released that model or if anyone can try it out. Maybe I've missed that, but it would be cool if we could try it out. But yeah, I think there's two. It's pretty exciting. First of all, they're just not using tokenizations. That's what they mean by the end of the tokens, not necessarily like the length of like the context length that you can feed into the model, but they're not actually doing tokenization. So tokenization is when like you have a sentence and you have to somehow represent that in and split it in tokens to feed it into the language model. And so far with most transformers models are splitting it into not words, but sub-words that are commonly used, and those are tokens, and that's the tokenization. And like how you do tokenization matters And this paper by Meta is just doing away with tokenization, essentially, and representing everything as bytes, which was not possible until now, but it will mean simplifying the training of the language models and making it into an actual end-to-end process, which is quite exciting. And then the other thing they're doing is splitting it into two different predictive models, essentially. One that predicts the next sequence of bytes, and one that predicts in batch the next bytes. And one can be a lot smaller, and the advantage of that is that then they can the costs of training a model are lower. Instead of being quadratic with context size, it's like to the power of 4 divided by 3, which will mean that with the same resources, we can train bigger models with larger context sizes, essentially, which is pretty cool.
This is a game changer, is it not? Because I think the major limitation of transformers right now, although it's also the major kind of benefit or powerful aspect of it as well, as self-attention, in that self-attention is the main mechanism that generates the accuracy of the models, but also the main mechanism that holds transformers back, because as Alex P was saying there, it means the complexity of the models, as in the efficiency, is quadratic in the input size. So if you put in 256 characters, then 256 squared or also could be the complexity. But by using bytes rather than tokens being loosely equivalent to words for those who don't know, by using bytes instead, it looks like we're getting rid of that limitation, thereby being able to input and output massive amounts of text, which is where transformers currently are limited, if I understand it correctly.
Yeah, I'm not sure about massive, but more than before, at least, right? So it will mean that we can, with the same compute, train larger models. And I guess one of the limitations for large language model progress is compute power, right? So we're limited by Moore's law, essentially. We only get like that much more compute power per year, let's say. But with new breakthroughs in the modeling side like this, where we can train better models given the same compute, then that helps a lot in making progress quicker. I do agree, though. Yeah, it is a game changer. It remains to be seen how well this scales in practice, and whether the models that will be trained with this will be as good as regular transformers models, right? Because there's been plenty of other papers that claim similar things, but then kind of they die out or nothing happens with them because there's other hidden disadvantages. So it remains to be seen whether this will be a game changer or not, but it does sound like one.
The article has a couple of paragraphs I think I just want to read, because it makes more sense to me to read it than to understand the way you guys were just speaking about it. So that's probably just coming from my perspective of ignorance. But the patch model, which is what you're effectively talking about with bytes rather than tokens, I think, enables Megabyte to perform calculations in parallel, in stark contrast to traditional transformers, which perform computations serially. So that makes sense, because we're talking about sequence to sequence and various things. I'm guessing that's reference to serial computation rather than parallel or parallelized, which is always a very difficult word to say. Even when a base model has more parameters, this results in significant efficiencies. So Megabyte, utilizing a 1.5 billion parameter model, could generate sequences 40% quicker than a transformer model operating on 350 million parameters. Now, those sorts of numbers and the perspective doesn't actually compute with me. But the next paragraph, I think, is really interesting. And this is why I brought it up and why I thought it was a game changer. But I think you guys, have really interesting angles on it. So admittedly, this is research, right? But using several tests to determine the limits of this approach, researchers discovered that the Megabyte's model's maximum capacity exceeded 1.2 million tokens. For comparison, OpenAI's GPT-4 has a limit of 32,000 tokens, although I don't yet know anyone who has access to the 32K token in one prompt, right? It's just sort of serial 2K token limits or 2K input, 2K output, 2K input, 2K output. So 8 stringed together. Anyway, we could get onto that. And Anthropic's Claude has a limit of 100,000 tokens. So that to me sounds like massively a game changer if, as you say, Alex, this isn't just research speak, but it can be practically implemented and usable by you and I.
Yeah, I didn't see that part about the millions of tokens. That does sound pretty cool.
It also feels like, again, I haven't read the paper, I'm just looking at it now, but it's interesting because one wonders why we ever indexed on tokens. We've talked a lot about transformers being sequence to sequence, and autoregressive models, which are essentially taking past time steps and computing the next time step, talk about time steps. So if the problem was financial forecasting, you could have every day or every week as a data point. In NLP, that equates to every word or every token. But I guess what we're saying here is, why limit ourselves to a token as the item to index on? Why not use bytes, which could encode more information and be less limited and maybe smaller in size, as in compute power?
This is only possible though, Rafi. So the reason we're using tokens is because of performance. So we could not do the same thing with bytes, but this becomes possible because of the other thing that this paper introduces, which is this split into a global and local module, essentially. So they're doing a 2-pass decoding with which is what enables them to do more efficient calculations and have sub-quadratic self-attention. So if I understand correctly, and I also need to read the paper carefully, but if I understand correctly, this is what allows them then to do away with tokenization and just go straight to bytes.
Yeah.
So it's not the bytes that enable them to be more efficient. It's this other architecture that they're splitting the model in 2 parts, and that enables them to use bytes instead of tokens.
Yeah, that makes sense. I guess it's this multi-scale transformer and cross-patch attention they're talking about.
Yeah.
Yeah. Cool.
All right, moving on to the next piece of news. I saw there was a MedPaLM piece. I presume that's you, Alex?
Yeah, I'm pretty excited about that, having worked in healthcare before. And it seems that when Google initially announced this model, they mentioned that it passed a medical exam with 85% accuracy, and that human doctors preferred the answers that this model gave compared to actual human answers, which is pretty exciting for me. We saw this already when working on medical note generation in a previous company I was working at. Sometimes, because the model's answers are so eloquently and nicely written, they are often preferred to actual notes written by human doctors. The problem, though, is that other times you have hallucinations. And this is something that we haven't solved and something that is quite dangerous in healthcare. So I wonder how Google's new model is doing with that. Be really keen to try it out.
Yeah, it sounds like I remember Michio Kaku, is that his name? Yes, Michio Kaku. And reading a book of his called Science of the Future. Amazing book where he sort of condenses his entire lifetime of sort of scientific research and reading and also sci-fi into what he imagines our future will look like. So it's quite fun for a futurist to read. I think it's probably about 5-8 years old now. One of the things it mentions is the idea that your mirror will be a doctor. So in the morning, you will walk into the bathroom and your bathroom mirror will just, function as a mirror to you, but actually it's analyzing the color of your skin, the bags under your eyes, the blood vessels in your eyeballs, the heat coming off you, like various different things, the oiliness of your hair, how much your facial hair has grown, like whatever all of these things are. And if it wants more data, it might just ask you something saying, how are you feeling this morning? Or do you have a headache this morning, right? And it may know that you have a headache before you even realize that you have a headache because of all of the way that it can understand you. And that really doesn't feel that far away when you take into account the hallucinations. Fine. I know I definitely don't want a doctor to hallucinate. I'm kind of okay with a medical AI hallucinating, but telling me, but you should check with a human doctor first. And the reason I bring this up is that someone on Reddit yesterday mentioned that they were having some strange symptoms after going to the gym. And they popped these symptoms into ChatGPT, which isn't MedPaLM 2 and performs worse on these accuracy ratings that you were just referring to. And it brought up this thing and said that if your pee is brown or red, then it's definitely this thing. Sure enough, half an hour later, he goes to the loo and his pee is brown. So he, based off ChatGPT's response, then knows what he has, rather than needing to see a doctor. Now, the entertaining thing is that he wrote this post on Reddit saying ChatGPT just saved my life. But really, it was him texting his girlfriend saying, ChatGPT just told me about this, and then my pee was brown. What should I do? And she's like, go to a doctor, you idiot. And everyone's like, ChatGPT didn't save your life, your girlfriend did. But put together MedPaLM 2, some basic video camera or recording tech, some simple sort of like decision tree questions, which I know Google has been working on for the last decade probably. And you have a version of Google Glass that isn't you looking out onto the world, but it's your mirror looking into you and being able to offer timely medical suggestions and advice and assistance. I'm really excited about that future. I imagine doctors are too, because so much of a doctor's job is just educating their patients. But if we all became a lot more clued up as part of our daily routines, brushing your teeth and you're just tapping your mirror because it's saying, how are you feeling? And it's like suggesting, oh, make sure that you eat some food that has this in, vitamin B2 tomorrow. And it's like, add kale to basket, whatever. I think that's coming.
There's a thing, I'm not a big Star Trek watcher, but there's a thing in Star Trek like that, right? The tricorder or something like that. We're getting there with our Apple Watches, I guess. That's it. All that information, I know it's a bit of a different topic, but all of that information that you get from your Apple Watch, for example, being accessible to you as a patient now is not necessarily something that doctors are excited by, because it's more annoying for a lot of doctors when you go to them with all that information and then have your mind made up about what you have and you're trying to get them to look at that information and use it, whereas they have other ways to proceed, right? There's too much information for doctors to take into account currently. If a patient goes to them with like all those heart rate readings and things like that, I've heard that from doctors that it's quite annoying that now patients have access to that information instead of the doctors on request when they feel that they need it. But yeah, I'm excited about that future as well. And we are kind of there, right? With our watches adding more and more functionality of that sort.
It's funny you say that about doctors, because I guess we are seeing a similar issue in law, because many of our clients go to law firms and they'll say, hey, I've got this Genie template for this software license agreement, and I've looked at several different versions, and I think these clauses should be included, and this IP clause should look like this. And that was never possible before. I've had at least one law firm tell me that. And, my view is actually that that's a good thing. And looking at the way that Alex D was talking about the future of medical diagnosis, if I can put it that way, I think we should try to rethink the way GP services are delivered, because essentially all they're doing is triaging the problem and following decision trees. And there's no reason why AI can't do that smarter and better and collect way more information and pass way more information way faster. Of course, there's all the problems about accuracy and insurance and mistakes, but these problems are just a matter of time in terms of solving them.
So on the matter of time element, and I totally agree with you. I think you've heard that from more than one law firm. I've also heard it from more than one lawyer. What's interesting to me is that they express it not as a win, but as a point of frustration for them, because they then feel like they don't just have to start from the document from scratch, which they're used to doing, right? That's the way of doing things in the past, but they actually then have to take and respond to all of the things that the client thinks that they want to do. And if they've made edits to the template, then they have to also consider what the template was before, how it's been edited, and whether that's suitable for the client's needs. So there's definitely a complex gap to break down there. On the time element, I was just listening to, I think this was a Bloomberg Intelligence podcast about the adoption of AI tools in enterprises. I don't have the article, but to be honest, the result is not going to surprise anyone. The age group that is most keen to adopt AI technologies across the board is Gen Z. And this could be a generational thing. I'm not sure that our parents are going to be comfortable using AI diagnosis tools. I sure as hell am. And I'm sure there are lots of other early adopters. And I think because we're in the hype cycle, because it's our bread and butter as well as an AI company, and because we're not yet our parents' age, let's say, it feels like all of these things are very, very exciting. And therefore the change is going to happen quickly, because we've seen the pace of change with all of this new tech. It does make sense that we should be thinking in a 10-year time horizon though, and think about how the 18-year-old today who loves AI is going to be using AI as a 28-year-old, given that it's a part of their life. I don't think thinking about how a 48-year-old is going to use AI is going to be that different when they're 58. So there's definitely a sort of demographic aspect to how quickly this future will be realized. And if anything, I think there's going to be a greater generational divide than perhaps there has ever been before, which maybe is it's a total tangent. So take that or leave it.
I love that. I think it's a really astute point, Alex D. It almost feels like on the generational gap that has been getting wider ever since the Industrial Revolution, and each movement in tech innovation just makes that gap wider and wider. But it almost feels like, as you say, those above a certain age, we almost shouldn't worry about building for them or their UX, which sounds terrible to say, but they may never shift just simply because of their stage of life. Whereas the newer generations just embrace everything. And that's also not necessarily a totally good thing either, because one problem with technological innovation and culture is that the newer generation will always accept the status quo as fine and normal, whatever that status quo is, even if that status quo is bad. No one really knows if TikTok is good or bad culturally in absolute terms. Probably if you're being tech positive, it's a good thing. But if it were a bad thing, the new generation would never know. They would just accept it as the norm. But for innovators, yes, the new generation is probably where we should be aiming at.
All right. Any more news?
Probably one more from me, if I may. That's a paper released by Meta last week entitled LIMA, a new model. Less is more for alignment. And it's a fairly standard transformer paper, except they've released this 65 billion parameter model, which is not fine-tuned using reinforcement learning, or RLHF, as they often say, but simply fine-tuned by retraining on only 1,000 carefully curated prompts and responses. And they find that fine-tuning on this very small data set makes the model outperform GPT-4 in around 40 to 50% of cases, and BARD and other big models in 50 to 60% of cases. And that's fascinating because it shows that what they call the superficial alignment hypothesis is true, which means that the majority of what a model has learned and its capability comes from pre-training. And so you could very easily adapt different models to different use cases and personalities with a small amount of data.
Meta seems to be in a roll with papers this week. We've featured 2 of them, but yeah, it's super exciting for me as well. It means that fine-tuning big models on human instructions is possible for smaller players as well, like ourselves as well, right? If all you need is 1,000 carefully selected examples, it's still expensive to produce those 1,000 examples, but it's doable as opposed to the data set sizes that we were talking about before.
Yeah, exactly. I think it kind of gives you hope. And there's a few other interesting aspects of this paper in that they evaluate, because, how do you evaluate qualitative responses? We always have this issue. So they use human evaluators and they just do a relative preference test. They just rank preferred responses, which is interesting. And then they actually use GPT-4 to do the ranking. And they find that GPT-4 roughly correlates quite well to the human evaluators, which is quite interesting as well from our perspective.
I think this goes on quite nicely to the theme that we picked up last week. One final thing, by the way, just for anyone who is, anyone who's a ChatGPT Plus user will already know this, but the plugins for ChatGPT are now available to all paying users. And there are more and more each day. There are even plugins to tell you which plugins you want to use, which is reminiscent of like early App Store days where everything is just a wild west of nonsense. So, perhaps beware, but if you don't know which tools you should be using, perhaps that is a good place to start. Lots of interesting plugins there. For example, ChatGPT can, browse links or read PDFs for you using these plugins, even if the model can't do it itself. So do check that out. Now,
Alex,
yes, go on, Rafi.
I'm sorry, I've just realized I think you have a sweet corn coming out of the sky. What is going on there?
I love that it's taken you this long to realize.
Because your face was covering it most of the time, so I just thought it was a streak of lightning, but it's clearly not.
No, this is a stable diffusion image, which I'm favoriting at the moment. I'm just a big fan. Someone tried to create a thunderstorm in a cornfield, and this is what it created. I love it. I don't know why I love it. I think because it's a mixture of sort of like dystopian madness, and yet everything is bright yellow, which is happy, and it's sweet corn, which is harmless. So it just feels like what's the word? I don't know, like a juxtaposition of what should happen in this situation. Also, if you have a look at the fields, you'll see that it's just like rows of perfect corn. So perfect.
Looking at it now, why are there clouds on the fields as well?
Yeah,
that's the problem.
And also, is it just me, or is there a person embedded in place of a few corn granules?
Is that actually a person? I think it's.
I don't think it's a person. I think it's just dark blue gab for some reason.
Someone ate that one corn.
Yeah. So some people have coined it the cornado.
The cornado.
Yeah. And what have you got for us, Alex, image-wise?
I think I forgot, to be honest, but I think I just put like the title of this episode into DALL-E probably. So what was the title? Prompts and tokens. So this is a representation of prompts and tokens. Not sure why, but there you go.
Keeping the watercolor going though, which is quite nice. I think the watercolor AI images are very believable.
I agree. Yeah, I think that's why I'm in general favoring them.
The text is horrible though.
The text is horrible. Yeah. I find that Adobe's Firefly image generation produces more believable text and sometimes legible text. Not always, but yeah, whenever DALL-E tries to write stuff, it's kind of yeah, not actual English letter alphabets, at least, which might be nice, right? It's like a more abstract representation of language.
I quite like it. Oh, it's absolutely awful for generating marketing collateral, because, for example, if I want, an image of AI legal assistant, or like someone joyfully, throwing a paper document in the bin or something like that, and then like going towards AI. The AI generation of the text on a legal document is awful. It's just like gibberish text. It can't even get a title of it. It gives it like a title, and then it like does some formatting stuff. But also sometimes the blocks are like really crunched up, and then in one column it's quite uneven, and then so it just doesn't look good at all. And you end up looking at that and thinking, this is unusable. I know there are some tools that are trying to fix that, and I'm sure I could fix it with a little bit of image editing, but you kind of want to end to end, which is an ongoing desire we have for these tools.
Maybe you should just use Alex and Rafi's happy people as your marketing image and go viral with a Genie AI logo and these happy people in the background.
it just also looks like they've all had plastic surgery or their faces are melting, or both.
I'm pretty sure the guy on the far left has 3 eyes. That eyebrow has become an eye.
Nothing wrong with having 3 eyes, extra vision.
So let's talk, Rafi, I don't think you got to speak to us at all about how you refine prompts and what your tips might be. I wondered if you wanted to share how this has changed as well. I think that's quite interesting, and sort of where we are today when we're playing with these things.
Yeah, sure. I think Alex P is doing this day to day, and so we'll also have some fascinating insights. From my perspective, I started using what's now called prompt engineering when transformers first came out, and some papers back then were calling it model conditioning, which I'm kind of sad as a term didn't survive. But at the time, what people were saying is, you train models on past data, but then with transformers being autoregressive, meaning you can take more data at each time step, and that will impact the output. You can give it more tokens, more words at test time. And this is basically prompt engineering in its rawest form. But practically speaking, when you know those sorts of mechanics and how things work, some practical tips that work are knowing how the model was trained. So many of these models, at least historically, were trained on question answering systems. So if you put Q : write your question, and then A : space, often it will give an answer to your question better than if you had phrased it in a more abstract way. Although nowadays the models are trained more generally, so that might not work as well. One example that does, or one tactic that works really well, is to give it many examples of what you expect. So if you want your answer in a certain style, then to give it, for example, questions and answers in that very style before ending the prompt with your final question. And then there's a trade-off between specificity and generality. Generally, the more specific you are, the better answer you will get. But at the same time, sometimes you just want the answer without having to specify everything. There's a balance there. So those are some quick tips. There's definitely a lot more which we can cover as we go along.
And how would you say that's changed with the generality? I'm guessing as the models have got larger and the emergent capabilities have come out. Maybe that's a bit of a silly reference to bring in here, but for example, a model that used to be trained mostly on Q&As, let's say the entire Cura set of questions and answers, would be predisposed to answer eloquently in a question and answer format. But now more general models that are trained on everything, podcast transcripts through to, every website, every Wikipedia page, every Reddit post, every whatever, the entire public internet, right? And we mentioned a link a few weeks back where you can go and you can see what websites have been used to train these models. Are you just as able to be specific with the larger models? And are the responses as good as when it was in the past, where you had a model that was more finely trained, let's say, or more nichely trained?
Yeah, well, maybe Alex P, do you want to take that? I think you had some thoughts there.
One thing to say is that in addition to being able to train it on a lot more data. One thing that changed with the latest generation of models is training it on instruct data specifically. So the RLHF training mechanism that Rafi was talking about earlier, where you take a model that was trained on the whole of the internet, but then fine tune it on specific human instructions. So I feel that's another part of why the newer models are so good at following like loose descriptions of what you want to do. I'm pretty sure that you can still condition them with things like Q&A, and they will understand that and give you an answer, and understand that Q is the question and A is the answer. But now you don't have to be that descriptive, and you can just describe in loose language what you want the model to do. I remember one of my favorite things was one of those early models. You could just write TLDR at the bottom and get a summary of the text that you just entered. I'm not sure if that answers your question, Alex, but I do feel that the instruct fine-tuning plays a crucial role here in the ability of the models to follow instructions.
Is a model's ability to follow instructions affected by the temperature that you're using for the output? For example, I've generated some markdown. Well, I've generated content, and then I've asked the content to be reformatted in markdown. I find it easier to do chunking of those things. If I asked it to generate the content in markdown, it would be worse overall. So that there's an interesting element there, right? Why is it that breaking up your prompts is better than asking it to do multiple? But also, sometimes even when I take the content that I've got, however it is formatted, it doesn't matter, and I ask it to format it in markdown, 95% of the time it does a fantastic job. Sometimes it just doesn't do it. And I guess this goes on to the question of how do you fine-tune prompts? How do you troubleshoot? I end up getting fairly good responses, but even when I've done 1,000 of those, I might still find 8 that didn't quite come out right. And then I just redo them and they come out right. So it's not like the input skewed it. So what's happening there? I imagine that's a fairly common problem.
It is, yeah. I've found that consistency is quite a problem sometimes in trying to get especially answers of that sort, where you want them in a very specific format like markdown or other programmatic formats. Temperature definitely does play a role there. If you do want structured format, it's better to try with a temperature of 0, because a higher temperature means that the model would be more adventurous and pick lower probability words sometimes, and then that just breaks your formatting, right? And then it can just deviate and go off from there. But in general, I do believe that it's still a problem, consistency, especially when you're trying to do something like that. So maybe what you're doing, Alex, is what you should be doing, which is ignore those cases and just rerun. If you're running those prompts programmatically and need to pass the output, you can just capture that as an error, I guess, and just retry, right? And then just accept that sometimes the answer that you'll get is not going to conform to the instructions that you gave it. One thing that I found helps a lot, though, with producing, for example, markdown, is if you finish your question with the start of the markdown tag, for example, that you want the model to complete, then that forces it to not just provide a random answer, but continue your markdown format.
And I think that point by Alex P is the key point, is just to always remember that what the model was really doing is predicting the next most probable sequence of tokens or words. And so if you always have that in mind, you can phrase your questions or instructions accordingly. Granted, the model is slightly tweaked, as Alex P mentioned, to handle instructions rather than just any old text, but you need to give it the input sequence of words that are most likely to generate your desired output sequence of words. And that's kind of the way to think about it.
Nice. So if you're being creative and you want to generate an article, let's say, then fairly high temperature means that you might get slightly more unique spins on things and a little bit less more like median boring. And then if you wanted to format that in a particular way so you could use it in your CMS, then you would bring the temperature down to 0, specify an example where it's formatted exactly how you want it, and then start with like output : or start with, you know, hash, and then, well, or just start with hash, and then hopefully it puts the title or the heading 1 for you as you might want it to be. I think that makes sense. I think probably what I was doing wrong is I was still using a fairly high temperature model to do the reformatting. I think I'd lowered it to 0.3 or something, which would have reduced the risk. But for me, I was just slightly worried about putting it to temperature 0, because sometimes when you put it to temperature 0, it just doesn't change anything as well. So there's definitely a little bit of like tweaking to that. So great tips there from both of you. Thank you. Do all models have a temperature setting, or is that something that's unique to the OpenAI models?
It's not, no, it's a pretty standard form of decoding. So most models that are autoregressive or like all family of current large language models, you should be able to decode in a similar way.
So with the ones that are very consumer friendly, like Bard or Bing, they don't surface the temperature, do they? They don't surface the sort of, I don't know, back end tuning of the model tuning. Is that right? I'm not sure what you would call that sidebar of the different toggles and drag and drops that you can do.
Different decoding parameters, let's say. You are correct, but in the same way, ChatGPT does not expose that, right? If you go to the ChatGPT interface as opposed to the OpenAI Playground interface, you don't get those options. I'm pretty sure that in the APIs, they will expose those kinds of options. I haven't played yet with a PaLM API, but I think we do now. It is available for GSP subscribers, so people can try it out.
Yeah, just some useful terminology for the more technically minded listeners. These settings that you can change, such as temperature, are known as hyperparameters. And the parameters of the model are the weights which the model uses to learn about the data. So you have hyperparameters and parameters.
So with the work that we have been doing, which is to generate highly accurate legal answers to user queries related to their context, i.e. their industry, their company size, etc. What have been some of the sort of problems with some of the prompt engineering that we've been doing, or things that we thought that would be easy but actually have been really difficult? Because we're bringing senior lawyers into the process to do some of that human training that we mentioned earlier. So I'm interested to hear more about that. Also, how is that task for a human? What does it actually consist of? We're just a legal AI company. What we're doing, I imagine, is being replicated across various different industries so that specialist firms with specialist products can outperform the general models, probably by the end of the year, right?
So there's two questions here, I guess. So first of all, about how does the process of making a more specialized model look like. In the past, it used to be that you need a lot of annotated examples, and then you fine-tune the model based on those examples. So you take one general model, and then you take a lot of data showing like what your model should be doing, but is not currently doing. And then you're actually changing the weights of the model to make it more likely to produce the answers that you want. With prompt engineering, though, this process is changing. And in essence, what it looks like is that you need to take a lot of domain knowledge and encode it into your prompts. This can be either in the form of giving specific examples, like Rafi was mentioning earlier, although there the challenge is to give representative examples that the model can generalize from. But it also means that you need to take the domain knowledge and encode it into the prompt itself. Like, for example, some ways to do that is to give the model context into the prompt about the kind of role that it's supposed to perform. We mentioned this in the last episode as well, where you need to tell it that you are a legal advisor doing this and that for that company. But you also need to give it the same kind of contextual information that an actual professional would need in order to make informed replies, right? And the challenge there, and the main challenge that I've found at least, is to make sure that the model takes that context into consideration. And it's not easy. Sometimes you just give context to the model, but it doesn't know how to use it. So you need to build something into the prompt that lets it know how to use that context.
With token limits, there's a limit to the amount of context. Do we come across that often, like struggling to get all of the context that we need succinct enough and formatted in the correct way, the correct structured way for the role-tailored assistant to respond in as accurate a way as possible? Or do we sometimes have to say, we have to just take this out because we can't put that in every time because it's too expensive, it makes the prompt too large? Because sometimes, we talked about succinctness of prompts very briefly in the last episode and how succinct is actually good. But the more we put in the prompt, the less succinct the prompt is. Or does the model kind of think about it differently, where you tailor the role, you provide the context, and then there's the prompt?
So for context length limitations, I don't think the problem is the prompts themselves, but any other information that you're passing along with the prompts. For example, when working on the legal domain, you want the model to do something, but you want the model to do something on a document, right? So you need to pass it that document plus the prompt explaining whatever you want it to do. So that's where you come into problems with the context size, because most legal documents are, at this point at least, larger than the large language model context sizes. Hopefully this will be solved in the short-term future, right? But for now, that's still a major problem. And then the challenge is knowing how to split your document into multiple chunks that fit into the context size, how to produce the right query to operate on each of those chunks, and then how to combine the answers from each query into a final answer. So there's several techniques there, and but that is the challenge there. That said, you also touched on another issue of prompt succinctness, if that is a word. And that's a problem as well, right? You cannot just keep cramming instructions and informations into the prompt and expect the model to be able to answer. At some point, it just starts ignoring the instructions that you've been giving it. So what you need to do is to do a task breakdown essentially, and per task give it the right instructions. So you need something more flexible than just cram all instructions about how to be a legal advisor into a single prompt and then just allow the model to do it. You need to break your task down in a way.
Curious to know what you think, Rafi, or how you've been dabbling with this over the last few years. I mean, ultimately, you've been trying to build, well, we have been building an AI legal assistant for 5 years, right? So there's been lots of prompts, lots of tweaks, lots of fine tuning, lots of context giving. You know, where do you come across issues? And I imagine it's the same for other industry specific AI companies out there.
Well, I think it's interesting. You talk about the last 5 years and the short history of this field. It's interesting that many companies that have been operating in legal AI for, prior to the last year or two, most of them, if not all of them, would have been taking a supervised learning approach or an unsupervised learning approach, meaning that in the first case, they would have been training their model on annotated data. And probably they've been building their applications to naturally create structured labeled data. And this is quite a long and painful process. I know a couple of companies that have really been working on their app to make that possible. And, we built our app to be structured as well. But we didn't invest too much into a certain AI approach, largely because of UX wins of other approaches. And as a result, we're now well poised to really take advantage of the generative AI authentic approach, whereas many companies now have these megalithic architectures built on labeling and training supervised models, which probably aren't even doing that well, and are certainly not very flexible in terms of adapting to other tasks apart from the given task. So I think that's just an interesting fact, because companies that start now or have a fresh approach now may even have an advantage over older companies.
One place where fine-tuning will be important, though, is instruct fine-tuning. We were talking about that LIMA paper from Meta earlier, Rafi, right? Where just 1,000 examples of good instructions are enough to build a pretty good model. And I feel that if those 1,000 instructions are domain specific as well, you can probably build an amazing model that handles domain specific knowledge without having to encode so much into the prompt instead. So I'm looking forward to that as well.
Yeah, I totally agree. I think there's still a lot of value in fine-tuning and improving models that way. On that paper, something I was thinking about is, I suppose what they were trying to do is not enable the model to learn new things or have new capabilities, but just have a different style or different approach, and for that to be preferred by the human evaluators. I feel like perhaps in our case and many other companies, let's take the example of law, specifically legislation and case law. Current models, including GPT-4, are not very good at understanding and retrieving and outputting case law, mostly because that data isn't easily available on the internet, although it is possible to extract it. And so in this case, fine-tuning on a small amount of case law examples, I don't know if that would be effective, because you're not adapting the style. It's more like the ability to retrieve case law doesn't exist in the first place in the entire data set or model parameters.
Yeah, in that case, what is the most exciting approach, in my opinion, is tool usage. So just like a human lawyer, you might know a lot of case law by heart, but you always have the ability to look things up, right? And if you give that ability to the models and use their reasoning capabilities to figure out when they need to look things up and when they feel that they know something, that's a really powerful tool as well that solves this problem.
So really crudely speaking, some ChatGPT plugins do this sort of thing, right?
Exactly. Yeah, that's exactly what all plugins do essentially.
But also, we don't just use GPT-4 for our AI legal assistants. We use other models. How do we choose when we use one model over another, and when one model complements the job to be done and solving that for the user? You know, so there's open source models, there's new models, there's going to be larger and better models in the next 6 months, I'm sure. I have no doubt. If you think about the last 6 months as anything to go by. It fascinates me to think that there are some startups that have these megalithic architectures and some startups that have been created that just use GPT-4 and already have millions of users. Now, obviously, they're all subject to creative destruction as things change, but how do we play that defensively in a way where all we're really interested in is providing instant, highly accurate, reliable, transparent answers to our users, to their legal questions? Because some models will be able to show they're working more than GPT-4 will, for example. And like, how do we use complementing models? How do models use other models as well? Like, is that a thing that's coming? Is that a thing that already exists?
I think we might not give away too much about our approach, but what I will say on model selection is that I think historically the prevailing thought in the industry was that you would build a specialized model for each task, and so you'd have a model to do task A, another model for task B. Then things change with transformers because now you have these massive LLMs that can kind of do everything. But they still can't do everything. And that's where you may need certain other models for certain tasks. And that's something we are likely to work on going forwards.
And those models are, Alex, are just like tools, right? So just like the plugins, some plugins could be other models that the foundation model is calling. Some plugins could be just like programmatic old school tools that like a lookup, for example, that the foundation model can be calling. So there's one big model orchestrating things and knowing when to use specialized tools. And some of those tools could be models themselves, right? That are more specialized and can do one thing better than the big orchestrating model.
Got it. I mean, this area just fascinates me, but we shouldn't give away the farm, as Rafi says. That being said, always open to talk about these things with people. So if you're interested in more about what we do get in touch. Crazy things we saw this week. I'm going to go with the first one, which I just absolutely love, and I think ties into the Gen Z stuff we were talking about. So imagine you're interviewing for a job and you've got Zoom up. And the interviewer asks you a question very specific about the domain. Let's say this is a banking interview, and you're supposed to demonstrate that you're, a top economics student. And they ask you a question. So there's this guy who's created a GPT-4 powered live transcription tool that then also answers the questions that you're asked in the interview for you. So you can side by side have the interview, and you can have the answers to the interview questions appearing in parallel. And as a hiring manager, I think this is a very interesting development. And we're going to see more and more, we already don't have written tasks, or we do live competency-based tasks for exactly this reason. Usage of tools is an element of competency these days, and I think increasingly will be, especially for the younger generation. But yeah, fascinated to see it. I'll plonk the YouTube video in the show notes. So if anyone provides AI generated answers in an interview, it may be because they're using this tool.
In general, I love these tools that are real-time transcription plus AI. When we're building note generation for doctors as well, it was similar to that. So you wanted a summary of the clinical encounter to appear on your screen in real time, as opposed to at the end of the consultation. So I think that's a really, really powerful paradigm, just to transcribe everything and then do whatever you want in it. It could be very useful for meetings as well, right? Like real-time summarization while you're having that meeting, as opposed to the end of the meeting, like most of the summarization tools do.
Yeah, speaking of meeting summarization, I think Clearword, which I've been using, does do it in real time, but I just hide it because it's quite annoying. But that said, neither Clearword nor Tactic, the two I've been using, produce summaries that are that great. And it strikes me it's not a difficult problem now with the state of LLMs. So that's just a bit of a frustration of mine, that why can't they just give a succinct summary and action points and post it in Slack? So if anyone knows such a tool, then give me a shout.
I agree. They have been tricky to find. I'm happy to keep going with the crazy things, unless either of you. I mean, to be fair, I shared one in Slack almost a week ago, and I just think it's amazing. It's this thing called DragGAN. Alex, you've been playing with this or looking at this a little bit, haven't you?
I have, yeah. It's crazy. It seems to work very, very well. So what it does is that it gives you an interface where you can modify a given image by dragging and dropping certain points. So, for example, you have a fashion photo with the model wearing certain clothes. By dragging the end of the clothes to different points of the model's body, you can change like the length of a skirt, and then the output looks super for the realistic. Or by changing the dimensions of a car, you get a car that looks exactly the same but in different dimensions, right? It also works with perspective. So if you turn a person's nose a bit, for example, they just turn the head towards that way. So it's pretty impressive, both because of the model capabilities, but also because of the, in a way, intuitive interface, right, where you just drag things and see them change. So it's pretty cool.
I just love that you can do things like like turn the face of a horse so it's actually looking the other way, and then somehow it melds the face with the rest of the body and the rest of the image so it looks like it's really natural. And it's just point-based image manipulation in a very, very cool way. And this happened, so this came out a week ago. There's a great GIF that just shows someone like mucking around and playing with it. I haven't played with it myself. And then it looks like Adobe have brought out something that is quite similar in terms of how it works. I don't know if either of you have seen the video about the generative AI within Photoshop. So it's sort of like Firefly 2.0, if you like, where you can have an image of, let's say, a tornado in the background, right? And so what I could do is I could drag and select this area, and I would say, turn this into a blue sky. with clouds that look like animals, right? And it would do that. I could grab the corn and say, turn this into a dystopian structure, and it would do that. And I could say, make this a field full of rainbow corn, right? And whether it would be red on one side, indigo on the other, or whether it would be rainbow corn, which is an actual type of corn, I don't know. But those sorts of things, I think, are amazing. So it just came out as something that, you know, almost looked sort of clunky and academic, and then Adobe have implemented it in Photoshop within the week. Obviously, they were working on it before, but it just goes to show that, like, the hackers are working as fast as big tech at the moment on some things.
Just saying, Alex, but Canva already has that feature.
All right, Rafi, let's give you like a whole 10-minute segment to tell us how amazing Canva is.
Go. All right. No, I'm joking.
That's quite cool. So does the Canva one work well?
Yeah, I haven't played with it much, to be honest, but I mean, the UX is pretty slick so far. I just realized that I was about to go on a rant about how great Canva is, but I stopped myself.
That's growth.
Yeah, personal development.
All right, I think let's wrap it up there, chaps. I think we'll only probably do another 3 or so episodes in this sort of first season. According to Podcharts, we're now ranking 50th or so in the UK in technology, which is very fun. So thank you everyone who has liked or shared or reviewed what we are doing here. Hopefully it just gives you a little bit of an insight to what it's like inside the boiler room of an AI startup whilst the tumultuous industry shifts around us. I think we're going to try and talk about AI companions next week, which is going to be a very interesting topic. So think like AI executive coaches, AI co-founder, AI girlfriend, AI boyfriend, AI parent, AI bestie, like best friend, like those sorts of things. They all exist now.
AI lawyer.
AI lawyer. I don't think we'll talk about AI lawyer because I think that if you come on Genie AI to use our AI legal assistant and you end up just wanting to be best pals, you should probably use the AI best friend tools out there, because our tool is going to keep advising you on legal aspects. We don't want that, unless that's what you want from your best friend. Maybe you don't know a lawyer. Maybe you want to know what it would be like to have a lawyer as a best friend. Come to Genie AI. Right, no, let's wrap it up there. Thank you, gents. And thank you for listening. And we will see you next week to talk about AI companions.
Goodbye.
Thanks both. Bye.